To show how to use PDF3D ReportGen for geospatial data, there's just a few simple steps in the menu to go through. First, we can use the Add File button in the corner to bring up a browser and find a suitable dataset for conversion. In this case, we can pick a simple ArcGIS ASCII grid file containing elevation data. Next, we can go to the interface settings and select a color map. The color map settings will basically be a rainbow to be applied over the surface, and we can decide that the color should be assigned to the elevation so we get some contours at higher elevations. Next, once we've specified that, we can specify the output file name as the 3D PDF that's going to be created, and then the Convert button at the top will launch the process of loading the data, creating the 3D shaded surface, producing the PDF, and then opening that for review. So here we have the resulting PDF that we can see on the screen, which can be zoomed, rotate, panned to reveal the various elevation contours that were converted from the original data. At the same time, you can see a legend bar has been created on the side so that we can read out some of the elevation data as we review this tile. To specify geospatial coordinates, we can enable the Coordinate System tab, set a projected UTM zone, and pick the appropriate WGS84 and EPSG coding for this particular data set. In addition, we can go to the PDF3D View tab, select Geospatial preset views, and also insert some controls to be added to the PDF page, including a probe control and a Z-scaling control. With those simple additions, we can convert again, and this time see the results of our ArcGIS ASCII grid file, this time being shown both with shaded contours and also line contours. And if we look at the bottom of the page here, we now have probe controls added. By left mouse clicking on the surface, a yellow arrow is shown at the current pick location, and the latitude and longitude and geodetic coordinates are shown in the box below, and this can also be switched to UTM zone reporting. So now we can see the zone ID, 10T, and the eastings and northings offset within this zone tile. In addition, the control has other options such as grade, so we can take measurements and distance along any two-click points, in fact showing here grade in percentage, angle, and ratio. Distance can also be reported from any 2 points by a similar 2-point mouse click, and this time showing distance in both projected and true 3D measurements. The view orientations at the top here are geospatially oriented, so we can set a standard plan view. Let's just turn off our probe for a moment, and we can switch to south elevation, west elevation, southeast elevation, isometric, etc. While we have 3D data present within our view, you can also set Z-scaling to arbitrarily change the magnification factor for whatever data set is appropriate for review. Once the elevation grid settings are established for our input ArcGIS ASCII grid file, we can also go to the Geospatial tab and select a geospatially referenced image to be draped over the surface. Here we can select an image which is appropriate for this data set. And in addition, we can go to the Gridding tab and enable a tin operation, which provides, rather than all the grid cells across the whole tile uniformly, will create adaptively sized triangle mesh appropriate to create a much smaller and more responsive PDF. So with those two changes, we can convert again, and this time the ArcGIS grid is loaded, but this time with the draped image and also an underlying tin grid for the representation. Here we also have contour lines shown, and if I switch to wireframe, you'll see the adaptive triangle mesh shown where the triangle density varies according to the curvature and features of the terrain. LiDAR point sample data can be converted from a number of formats, including LAS format or ASCII PTS, XYZ, XYZI, etc. Here we're loading a LAS file, and we can specify, first of all, how interpolation should be treated, and we have a choice here of just showing the points directly with no interpolation as a good starting point, and then we can add a color map which we can apply along the elevation of the points to reveal some of the geometric structure. So with those two settings, we can convert and see the result of all of our points loaded and displayed directly in a 3D PDF file. Here's the example that we've just created, and you can see here that the elevation of the points have been banded into different vertical sections according to the color in our color table loaded on the side here with some numerical tags showing us the actual elevation of the points. Next, we could change this to look at the attribute settings. LiDAR often has attributes such as intensity, return, or reflectance values from the laser. And here we can use that to convert again, showing us the same color map, but this time applied to the attributes of the points. And here we have more material differentiation, where the background terrain base is showing some darker reds. We see some street or roads featured in tan, and we have the tree canopy showing in green. LiDAR data often can be large, and there's several ways of controlling that when the PDF is generated. First of all, the subsampling parameter can be set to whatever value is appropriate, such as 10 or 100, which means to read every nth point from the input file. And secondly, the Advanced tab has a simplification option where a budget can be set, for instance, how many output points should be created in the PDF, subsampling the input with a mathematically accurate quadratic error measure control system.